Our last method is to use regression analysis to analyze our cost behavior. For regression analysis, what companies do is they run their data sets through a program like Excel. This is actually an Excel output, and it will give you a bunch of data that looks like this. So your output looks like this. The three highlighted things are what you need to be concerned about, and we'll talk about each of them. So what is regression analysis? It's just a statistical procedure to find the line that best fits the data that we have input. So basically, the regression analysis, what it does is it calculates your cost equation for you. The good thing about regression analysis is that it uses all your data points. Whenever you're looking at a regression analysis, the three things that you need to find are your R square, which is right here, and you need to look at the value of your R square, your intercept, and your X variable. So those are the three things that you need to pull out from this analysis. So let's take a look at what all these highlighted items mean. The intercept. The intercept is your fixed cost. So you see your intercept right down here. Your intercept is your fixed cost. So what is your fixed cost? Your fixed cost is $14,538.05. The next one that you're going to take a look at is your X variable 1. X variable 1 again is right here, and X variable 1 represents your variable cost per unit, which is, if you round it up, it's 7.65. So you get both your F, which is your intercept, and you get your V, which is your variable cost per unit. The third item here is your R square. R square is called the goodness of fit, and basically the value of the R square shows you how well the data points fit your cost equation, whether you should rely on your cost equation or not. So that's what the R square shows. So with the information that you have here, let's write out our cost equation. You know that your cost equation equals y equals vx plus f. You know that v is your x variable, which you have put at 7.85, and your intercept is your fixed cost, which is 14,538. Now you can use this cost equation to predict cost at different volumes within your relevant range. Let's talk a little bit more about the R squared value. You know, the R squared value is what we call the goodness of fit, which means how well does the line fit the data points. And the value of R squared ranges from 0 to 1. The way this works is if the value is 0, that means there is no relationship between your data points and your cost equation. If the value is 1, there's a perfect relationship between your data points and your cost equation. So the higher the number, the closer it is to 1, the better your cost equation can predict your costs at different volumes. Let's go back and take another look at our R square from our output. How is our R square? Is it close to 0 or closer to 1? It is 0.95, which is close to 1, very close to 1. So our cost equation is a very good fit for our data point. So this is a good predictor. Our cost equation can predict cost very well because the R square is close to 1.